Hi everyone, in this video I'll break down mapping questions you commonly find in the past questions. Really common in the past questions. So the title of this playlist says limits, functions and continuity. Anywhere you see limits, any question on limits, you will usually find questions on mapping too. So that's why they are very important. They come up almost every time in the past questions. And that's why we're solving them in this video. If you are not subscribed already, make sure you do that right now. And let's get started. So look at this first question. Very common in the past question. You find a question like this: y is equal to the root of x minus 1. And then they're asking you to find the domain and the range. Common, typical mapping question. So if you find a question like this, first of all, what is domain and range, right? I'm just trying to explain something to you before we solve the questions. So let's say you have something like this. Let's say you have a set like this or a pot like this, and you have x, x1, x2. So let's say you have some things inside, and then you have another pot here. So these guys are independent, they are just on their own. Whenever I find this one and I solve for them, they will produce something, right? They will produce something like a mirror version of themselves. So they'll produce something inside here. So let's call this capital X and capital Y. So they'll produce something inside here like this. So the result of whenever of this is Y, and the result of this, let's say Y2, Y1. So that's everything about. So this is the domain. We need to find certain numbers that will reproduce another what's called, this is the range. So these ones are independent and these ones are depending on this one. So every time if we find this one, for example x, if we put x here as let's say 2 for example, it will produce y, right? If we put, let's say we have x plus 2 for example is equal to y, these ones here are independent. So all these variables here are independent. You can have, let's say when x is 1, when x is 2, when x is 3, when x is 4, whatever x is, or whatever we independently assume x as, right? So if you say x is 1, x is 2, just substitute x. If x is 1, that will be 1 plus 2. So y, which is a mirror, the image, will now be called the 3. So if x, when x is 2, for example, let's say x is 2 here, what is y? Y will be 4, right? So it's reproducing something. So that's what we are concerned, like the relationship between these guys reproducing something inside the range. So this is the domain and the range, and they're asking us to find the domain. So you know what the domain is now. The domain will be, let's assume we assign random numbers, real numbers, 1, 2, 3, 4, whatever. What are they reproducing that makes sense? That is everything about the domain and range. So let's solve one so it makes more sense to us. So for this one now, to find the domain, very easy. All we need to do is assume, let's say when x is 1 equal to 1, what happens to y? What is y? When x is equal to 1, what is y? When x is greater than 1, and if x is less than 1. So what happens to y? So that's what this is the domain. Let's just start with 1 because 1 is very close to the 1 is very easy to spot. So whenever I see a question like this, just start with 1 or anything that makes sense to you. If x is 1, so we're just trying the experiments now. What happens? This is y is equal to square root of x minus 1. So if x is 1, what is y? If x is 1, y will be the root of 0. And the root of 0 makes sense, right? The root of 0 is just 0. So that makes sense. So when x is equal to 1, y is equal to 0. Makes sense, right? So now, what happens when x is greater than 1? For example, let's assume this x is greater than 1. So we choose x is equal to 1. We're just testing things to find out what the domain and the range is, and it makes sense very soon. So now let's try any number from 2 and above, right? Greater than 1. So 2, 3, 4. Let's plug it inside here and see what we get. So if you put 2 inside for x, we'll get the root of 1. So 1 times 1 is 1. So now let's try another one. If x is 3, for example. So we tried if x was 2 before. If x is 2 here, we'll get 1. So if x is equal to 2, y is 1. Now if x is equal to 3 now, what is y? So y will be very easy. 2, this will be root 2, and root 2 is a number. We can find the square root of root 2 to give a decimal point. So if x is equal to 3, then y will be point something root 2. So all these things make sense. We tried when x is equal to 1, it makes sense. It gave us a number that makes sense. We tried when x is greater than 1, so 2, 3, like that. They gave us good numbers. What about when x is less than 1? Let's try that now to see how this goes. Let's try when this x, not y, when x now is 0, minus 1, minus 2. So let's try it. The root of let's say 0. If x is 0, that's minus 1, and that's the square root of minus 1, like this. Becomes the square root of minus 1. The square root of minus 1 is imaginary, and for mapping it doesn't make sense. We don't do imaginary number, so this is wrong. But you can already see that we tried when x is equal to 1. It makes sense, so that's cleared. We tried when x is greater than 1. It makes sense. Now we're trying x is less than 1, and it doesn't make sense. Let's try another example so you can see it very clearly. Minus 1, minus 1. You can see that every time we have a negative value for x, it gives us imaginary numbers, or numbers that doesn't make sense to us. So if you're having the square root of minus 2, it doesn't make sense. This is wrong. We can't have a negative number as our answer, so it's wrong. So this side is wrong. From our discussion, what is the domain and what is the range? So the domain, they are the set of individual elements, the one that we brought into the question. So remember, we just assumed let x be 1, let x be 2, and let x be 3. So let me draw the number line so you can see it. So you can see that this x is here can only be 1. That's the only way to make sense. Can only be 1 and above, like 1, 2, 3. Those numbers work. 1 and above, 1 and 1 when x is greater than 1. So 1 to infinity, to positive infinity, like this. So you get it, right? This is our x. Our x can only be equal to 1, and our x can only be x greater than 1. That is the domain. Those are the elements that were brought into the equation, independent elements that were brought into the question to make the y make sense, because we cannot have minus square root and all those things. So you need to try out different elements to know where the domain lies. So this is the domain. X is greater or equal to 1. Now you see the reason why it's greater or equal to 1, because if x should move to 0 or negative values, if x should dare move to 0 or minus, we can never map out the range that will make any sense. So now we can put this in this notation, that x is 1 like this to infinity like this. Put the number line so it makes sense to you. 1 to infinity, not inclusive. So 1 is inclusive, meaning if you see these brackets like this, it means inclusive, meaning 1 is among 1 to infinity, but I'm not adding infinity because I'm saying that my value for range is between 1 and infinity. But obviously you can never have infinity, so I'm not including infinity. If I should include infinity, it will look like this. You get? But I'm not adding that one because it doesn't make sense. I want my one to be 1, 2, 3, and to infinity, but it can never be equal to infinity. So 1 to infinity, not inclusive. So this is our domain. So what about the range? From what the domain, we got that the domain is x greater or equal to 1. So 1 and above is the domain. So the range now is whatever we get from this. Every time we put 1 and above inside here, what do we get? We got 0, and so y, which is the range, is greater or equal to 0, and above, like 0, 1, 2, keep getting numbers from 0 and above, right? So that's 0 to infinity. So our y, we'll just put it in a number line like this, that this is 0, and like this, you can see it's like this. It's greater, our y is greater or equal to 0. Every time we put this x greater or equal to 1, so like 1, 2, 3, 4, if we put them inside here, this independently put them inside here, we map out a range, like all these ones from 0, 1, like that, like that, like that, so to positive infinity. But it can never be infinity, so it's always going to be here and here. We're not going to reach all the sides, so let's put it inside this 0, inclusive of 0 to infinity, positive infinity, not inclusive of. So that's what the symbol means. So that's your answer for this question. Very easy.